everybody. Welcome to today's PlayPosit. We are going to get started with quadrilaterals in the coordinate plane, and we are also going to be talking about trapezoids in today's lesson. You can get today's notes from OMHS. They are posted there, as well as the key, and you are welcome to watch this video as many times as you need to. You can also reach out to me with any questions that you might generate throughout the lesson and join me during office hours. I'm happy to help. Okay, but today we are going to prove parallelograms in the coordinate plane. And when I say that, I mean we're going to determine properties about what we see and determine whether or not the quadrilateral we're looking at is a parallelogram. We can also determine whether or not it's a rectangle, a rhombus, a square, and we can do all of that in the coordinate plane. There's three ways that we can prove that the quadrilateral is a parallelogram, knowing the properties of the parallelogram. So for example, we know that parallelograms have opposite sides that are congruent. Okay, so if this quadrilateral here was graphed in the coordinate plane, then we would know that the opposite sides would be congruent. So we can write if, and for this example, we have AB congruent to CD because those are opposite sides. So if AB is congruent to CD and AD congruent to BC, then this quadrilateral would be a parallelogram. Okay, so if we can prove that property is true, we can prove it's a parallelogram. How would you prove that two segments are congruent? Well, you would have to find their length. And what equation do we use to find length? We use the distance formula to find length. So if you are trying to prove that two lengths on a coordinate plane are congruent, you're going to need to use the distance formula. Another way that we could prove that the quadrilateral is a parallelogram is by picking a different property. We know that in a parallelogram, your opposite sides are parallel. So AB would be parallel to DC with a B. And AD would have to be parallel to BC. So if that was true, then we have a parallelogram. And how can we prove that the lines are parallel? So thinking back to what we did in semester 1, we learned that lines are parallel when they have the same slope. So we would have to calculate the slope for these four segments. And if the opposite sides had the same slope, then they would be parallel. And this indeed would be a parallelogram. So you would have to use your slope formula. And then there's a third method to prove that the parallelogram is actually a parallelogram. And what you could do is you could prove that one pair of opposite sides are congruent and parallel at the same time. So you could say, oh, well, let's see, is AB parallel to DC and is AB congruent to DC? If both of those are true, so let's write that, AB congruent to CD and AB parallel to CD. If both of those are true, then you have a parallelogram. This is my least favorite one because you have to use two different formulas. You would have to use the distance formula to prove that the opposite sides are congruent. And then you would have to use the slope formula to prove that the opposite sides are parallel. If you want to do that, you're welcome to. Personally, I like the first two methods better. Okay, so let's look here. We have 4 coordinate points. And we want to determine whether or not this is a parallelogram. The directions here say using the distance formula. So we're going to use method 1, where you could graph these 4 points if you wished. And I'm going to just sketch it here so you have an idea of what it looks like. Here's my X and Y axis. A is at -7, 4. B is at 1, 2. C is at 9. -8, and D is at 1, -6. Okay, so just by sketching it, I can tell, okay, well, AB is the side across from DC, and AD is the side across from BC. If I want to prove it's a parallelogram, let's prove the opposite sides are congruent. So we're going to find that the length of AB, we're going to find the length of DC, the length of BC and the length of AD. And to find the length between 2 points means we're using the distance formula, which we memorized way back at the beginning of semester 1. It said you're going to subtract your x values and square them, plus then subtract your y values and square them. Maybe you memorized it slightly differently where yours says x2 minus x1 squared plus y2 minus y1 squared. It's the same thing. That's fine. All right, so for AB, we're using these 2 points. We're going to use the distance formula. X minus x squared plus y value minus y value squared. You may at this point use your calculator because we just want to know if they're equal. We don't really care what they are. We just want to make sure that they're equal. So if I were you, I would just plug this right into the calculator without the square root. I'll show you how I would do that in Desmos. Okay, so I'm sharing with you my Desmos screen. I'm using the graphing calculator. That's the testing calculator because this is the calculator that you would see on your SOL. So I want you to be used to that one. So if you're going to Desmos, you're picking the different types of calculators, pick the testing calculator and the graphing one. That's what the calculator will look like when you're taking an SOL. Notice that I have typed in exactly what was in my square root, but without the square root symbol. If you're looking for the square symbols on the calculator, you can click on that little keyboard and all of the other symbols that you're looking for are there. Okay, so I didn't type the square root because I just want to type square root of, I just want to answer square root 68 as my length. I don't want to round it because if I round it, then it's not an exact answer. So no rounding. Okay, so we're just going to write square root 68. There it is. And now we'll do the same thing for DC. So for DC, we're using the points D and C. X value minus X value squared plus Y value minus Y value squared. And then I can type that on into my Desmos. Okay, so let's do that. We will type in 9 minus 1 squared plus -8. Now you can type minus negative if you wanted. It will read it. I like to just combine. We know that minus and negative is the same as plus squared. So there we got 68 again. Okay, so we know that the length of DC is now the square root of 68. There we go. Does it matter, Ms. Grandy? Can I just write 68? No. Okay, 68 and the square root of 68 are completely different numbers. So just be careful. The length is not 68. The length is the square root of 68. I'm leaving it as the square root of 68, so I don't have to round it. Whatever they round to, these are the same. So now I know that AB is indeed congruent to DC. And now I'm going to do the same thing, but with BC and AD. Okay. So to find the length of BC, I'm looking at the coordinates for B and C, and I'm doing an X value minus an X value squared, and a Y value minus a Y value squared. I'm typing that into Desmos without using the square root, just so I know what number goes in the radical. So it's the square root of 164. I'm going to use the distance formula to find AD. X value minus X value squared plus Y value minus Y value squared. Type what's inside the radical into Desmos to simplify it, and we get 64 again. So the square root of AD is the square root, or the length of AD is the square root of 164. So now I know that AD is congruent to BC. I just proved that the opposite sides were congruent, so I can say yes, this is a parallelogram. So I'm going to say yes, ABCD is a parallelogram because opposite sides are congruent. Go ahead and try number 2. we have parallelogram PQRS. I want to know, is this a parallelogram? Okay, so you're going to test, are the opposite sides congruent? Use your distance formula to do that. And let's decide, do we have a parallelogram? Do that now. So you should have said that this was not a parallelogram. Okay, if you sketched it and you said, oh, it's not a parallelogram because it doesn't look like one, that wouldn't be an acceptable reason. You have to have some kind of mathematical, logical reason why. And so in this case, parallelograms exist when opposite sides are congruent. So if you tested the length of PQ, you got the square root of 104, and the length of RS, well, that's the square root of 82. Those are not the same numbers. So you could say it's not a parallelogram because the opposite sides are not congruent. So just be careful. If you're saying, oh, it's not one because it doesn't look like one, you need a little bit more reasoning than just that. And so you would have to give some kind of reason. The opposite sides are not congruent. The opposite sides are not parallel, something along those lines. Okay, so as soon as I got that PQ and RS were not equal, I could stop, because both sides of a parallelogram have to be congruent. And if even one side is not, then it's not a parallelogram. Okay, so now that was for parallelograms. What about our special parallelograms? The rectangles, the rhombus, the square. Okay, so if you want to classify a quadrilateral as one of these four things, you're going to need to first check the congruency of the sides. Okay. And then once you know the congruency of the sides, check the congruency of the diagonals. Okay. So if you have a parallelogram, your opposite sides will be congruent, but the diagonals won't be. If you have a rectangle, your opposite sides will be congruent and the diagonals will be congruent. If you have a rhombus, you're going to have four congruent sides, but not congruent diagonals. And if you have a square, you're going to have four congruent sides and the diagonals will be congruent. Hopefully this table helps you out. Okay. So looking at our first practice problem here, I have four coordinate points, and we need to determine the best, most specific classification. Okay. Maybe it's a parallelogram, or maybe it's a rectangle, a rhombus, or a square. Remember that a rectangle and a rhombus are parallelograms. They're just special parallelograms. And a square is a very special parallelogram where it has all the properties of rectangles, rhombuses, and the parallelogram itself. So first, what you're going to do is sketch this thing. What's it going to look like? Just so you know what sides are opposite what, and what are the names of the diagonals. So A is at 9, -4. If you wanted to like actually graph it, you could, but a sketch will be good enough for us here. B is at 8, -2. C is at 2, -5. And D is at 3, -7. All right. So now I see that side CB is across from side DA. The diagonals are AC and BD. So let's first check the length of AB, that's a side, the length of BC, the length of CD, and the length of DA or AD. We're going to check the length of the side, and then we're also going to check the length of the diagonals. So we're going to check the length of diagonal BD and the length of diagonal AC. So that's 6 times that we get to use our friend, the distance formula. So let's find AB, x minus x squared plus the y minus the y squared. So simplify what's in your radical there, we get the square root of 5. Let's find the length of BC. If you need to pause the video and type that in your calculator just to double check that square root 5, you are welcome to pause now and check that. All right, so for BC, we have an x minus an x value squared, y value minus y value squared. So the length of BC turns into the square root of 45. All right, let's find CD. So I'm using the point C and point D, x minus x squared plus a y value minus a y value squared. Simplify what's in your radical, and the length of CD is the square root of 5. Well, that's good. We've just proven that AB is congruent to CD. Let's see. Let's find the length of DA. So I'm using coordinates from D and from A. X value minus x value squared plus y value minus y value squared. Simplify what's in your radical, and we get the square root of 45. All right, awesome. Well, we've just proven that this is a parallelogram, okay, because the opposite sides are congruent. So it's a parallelogram. And there's one other option it could be. It could be a rectangle. So we might have to say rectangle is our answer. We cannot say that it's a square, and we cannot say that it's a rhombus because its 4 sides are not all the same length. So all we know is the opposite sides are congruent. All of the sides are not congruent. Okay, so it's either a parallelogram or a rectangle. So because it's a parallelogram or a rectangle, let's test those diagonals. If the diagonals are congruent, we've got a rectangle. If the diagonals are not congruent, then all we have is a parallelogram. So let's check for BD. So I'm using points B and D. X value minus x value squared plus y value minus y value squared. So the length of BD turns into the square root of 50. Let's find the length of the other diagonal. X value minus x value squared, y value minus y value squared. Simplify your radical, you get the square root of 50 again. So your diagonals are congruent. So the quadrilateral that has opposite sides congruent and congruent diagonals means that this must be a rectangle. Yes, it is a parallelogram also, because all rectangles are parallelograms. However, because those diagonals are congruent, we can say it is a very specific parallelogram, and we call it the rectangle. All right, here's another example, QRST. Can you tell me the most specific name of this quadrilateral? Is it just a parallelogram? Is it a rectangle? Is it a rhombus? Or is it a square? Go ahead and use your distance formula to find the lengths of the sides and the lengths of the diagonals. And based on the information you get, tell me what kind of quadrilateral are we looking at. Do that now. All right, so you should have said that this quadrilateral was a rhombus. You start out by finding the lengths of the 4 sides, QR, RS, ST, and TQ. And when you did that, you should get the square root of 13 for all 4 sides. So when you have a quadrilateral that has 4 congruent sides, you know that it is either a rhombus or a square, or a parallelogram. Right? So a parallelogram has opposite sides that are congruent, but then as soon as all 4 of them are congruent, then you know that it's not just a parallelogram. A more specific classification would be a rhombus. So we're not going to say parallelogram because a rhombus would be more specific. Now, could it be a square? Because the square would be an even more specific answer. So then you test the diagonals. And when you test the diagonals, SQ and RT, you should get SQ is 6 and RT is 4. Or maybe you just got square root 36 and square root 16. That's okay if you left them like that. But they're different. And they would have to be the same if they were a square. So because the diagonals are different, we have to go with rhombus. Okay. So all rhombuses are parallelograms. All rectangles are parallelograms. All squares are rhombuses, rectangles, and parallelograms. And when I say that means it has all those properties. Okay, so by proving that it had 4 congruent sides, we knew it had to be a rhombus, but maybe more specifically, it was a square. So in order to test whether or not it was a square, we had to test the diagonals. If the diagonals had been congruent and all of the sides were congruent, we would have said square. But because the diagonals were different, even though all the sides were the same length, we have to go with rhombus. Okay, let's look at these problems here. So in these problems, we're going to have to use what we know about the properties of our quadrilaterals and what we know about the slope, distance, and midpoint formulas to answer the question. So in number 1, it says we have parallelogram PQRS below. As soon as I read that, I know it's a parallelogram. It tells me it's a parallelogram. So every property of parallelograms count here. It says that if P is located at -1, 6, so I'm just going to go ahead and put -1, 6 right here, and S is located at -7, -3, what is the slope of QR? Okay, so if it's a parallelogram, that means the opposite sides are parallel. If lines are parallel, that means they have the same slope. So if I can find the slope of PS, that slope will be the same as the slope of QR. So we're going to find the slope of PS. Remember, we use that lowercase m for slope, and I like to do a little subscript of whatever I'm finding the slope of. So this is slope of PS equals. Remember, your slope formula says that you subtract your y values in the top. So 6 minus -3. My pen got a little messed up. Try that again. So y values in the top, x values in the bottom. Okay, well, 6 minus -3 is really 6 plus 3, that's 9. And -1 minus -7, really -1 plus 7, which is 6. You would never leave your answer that way because 9/6 does simplify to 3/2. So if the slope of PS is 3/2, then that means that the slope of QR is also 3/2. Because they are parallel, they have to have the same slope. On number 2, it says on rectangle ABCD below, A is located at 3, 4. B is located at 7, 6. What is the slope of BC? Okay, now it's a rectangle. So let's think about the properties we know about a rectangle. In a rectangle, the opposite sides are congruent, just like in a parallelogram. The diagonals are congruent, and you have 4 right angles in your rectangle. So knowing that, I see they give me information about AB, but they're asking me about BC. Ah, well, we know that in a rectangle, this would have to be 90 degrees. If that was true, if this was a 90-degree angle, then AB would have to be perpendicular to BC. And remember, lines that are perpendicular have opposite reciprocal slopes. So what we can do here is find out the slope of AB. And then when we know the slope of AB, we're going to take its opposite reciprocal, and that will be the slope of BC. So let's find the slope of AB. X value minus X value, Y value minus Y value on the top, and then X value minus X value on the bottom. 6 minus 4 is 2, and 7 minus 3 is 4. Well, 2/4 reduces to 1/2. So the slope of AB is 1/2. So the slope of BC is going to be the opposite reciprocal of that. The opposite of a positive is negative, and the reciprocal of 1/2 is 2/1. So the slope of BC is going to be -2 in order to force AB and BC to be perpendicular. If you need a review on slope and parallel and perpendicular, please let me know. I can send you any of the videos or notes that we had in semester 1 if you were not able to save those before the course closed. Let's look at number 3 on rhombus, WXYZ. Okay, rhombus. So if it's a rhombus, that means it has 4 congruent sides. It has diagonals that are not congruent, and its diagonals are perpendicular. W is located at -5, -2. Y is located at 3, -2. What is the slope of XZ? All right, so they gave me information about WY, that's a diagonal. They're asking me about XZ, another diagonal. In a rhombus, diagonals are perpendicular. So we're going to do a very similar process that we did up here in number 2. We're going to find the slope of WY. So we'll have a y value minus a y value over an x value minus an x value. Well, -2 minus -2 is really -2 plus 2, which is 0. So it doesn't even matter what we get in the denominator. What do we get here in -8? Well, 0 over -8 is 0. So the slope of wy is 0. So what will be the slope of xz, or the perpendicular slope? So what is the opposite reciprocal of 0? It's kind of a trick question. If you said undefined, you're right, because you can't have a 0 in the denominator. The other way you could think of it is wy is a horizontal line. And I know it's horizontal because its slope is 0. So any line that is perpendicular to a horizontal line, we call that a vertical line. So xz is a vertical line. And what is the slope of all vertical lines? They have undefined slope. All right, so let's look at example 4. Here I have squared JKLM. J is at -2, 5. K is at 2, 2. And it's asking us for the slope of LK. All right, well, this is a square. Squares have all of the properties of rectangles, all of the rectangles of rhombuses, and all of the properties of parallelograms. So squares have a lot going on. Because they gave me information about JK and they're asking me about LK, I'm going to ask myself, what relationship do those two segments have? They intersect, and because a square has properties of a rectangle, I know that this has to be a 90-degree angle. So in other words, JK is going to be perpendicular to LK. So I'm going to find the slope of JK, and that will tell me, or help me at least figure out what the slope of LK is. Go ahead and try this one. Find the slope of JK first, and then based on that information, tell me what will the slope of LK be. Try this one now. All right, you should have gotten the slope of JK was -3/4. And so because the slope of JK was -3/4, that means the slope of LK will be the opposite reciprocal. The opposite of a negative is positive, and the reciprocal of 3/4 is 4/3. So the slope of LK is a positive 4/3. All right, on number 5, we have a parallelogram. It gives us the coordinates of S and T, and it wants us to find the length of VU. All right, well, if we know the coordinate of S is at -4, 1, and T is at 5, 3, we want to know the length of VU. Knowing that in a parallelogram, opposite sides are congruent, we're going to find the length of ST, and whatever the length of ST is, will have to be the length of VU. So go ahead and calculate using the distance formula the length of ST. What is the length of ST? Do that now. All right, you should have gotten the square root of 85 as the length of ST. And so because ST is congruent to VU, you now know the length of VU. It has to be the same as ST, square root of 85. All right, let's look at number 6. Here we have a square where Q is at 7, 0, and R is at 5, -8. What is the length of SR? Use what you know about squares. Use what you know about the distance formula. Tell me, what is the length of SR? Try this one now. All right, in a square, all 4 sides are congruent. So you're going to find the length of RQ first using your distance formula. The length of RQ is the square root of 68. Well, all 4 sides have to be congruent in a square. So if the length of RQ is the square root of 68, that means that the length of SR is also the square root of 68. I'm going to let you try number 7 and number 8 on your own. Read the directions carefully. Ask yourself what you know about the properties of a rectangle, or number 8, the parallelogram. Properties that might include the lengths of sides, which sides are parallel, and the lengths of diagonals, all of that. So go ahead and read the directions very carefully. In number 7, I want to know what is the length of GE. And in number 8, let's see if you can figure out what the coordinates of point E are. Just try them, and then we'll go over them. So try these 2 now. All right, so for number 7, hopefully you looked at this, you recognize that GF was a diagonal. And in rectangles, diagonals are congruent. So if you could find the length of DF, then you know the length of GE. Using the distance formula, find the length of DF, you get the square root of 74. In a rectangle, diagonals are congruent. So if DF is the square root of 74, then that means the length of GE is also the square root of 74. Notice I'm not rounding many of these answers. I'm just leaving them the square root of a number, and that's okay. On number 8, it gave us the coordinates of the vertices of this parallelogram, but then it asked us about the coordinates of E. Remember, in a parallelogram, your diagonals bisect each other. So if it's bisecting each other, that means it's being cut in half. Or in other words, E is the midpoint of each diagonal. So the work that you see here, I found the midpoint of AC, and the coordinate of E was at 3, -2. You could have also found the midpoint of BD and gotten the same coordinate. Okay, so you have to remember the midpoint formula all the way back from semester 1. If that's something you need to study or practice, definitely go back to your notes from semester 1. If you need any extra, anything from semester 1 that you don't have, just let me know. I can send it to you. Okay, we also need to talk about trapezoids. Trapezoids are pretty easy. They don't have a whole lot of properties. We have non-isosceles trapezoids. So these properties go for all trapezoids where the legs are not the same. So if you have a non-isosceles trapezoid, you only have one pair of opposite sides that are parallel. So here's your parallel sides. Consecutive angles between parallel lines are supplementary. So that means that like this angle, we'll call it angle 1 and angle 2, will be supplementary. And angle 3 and angle 4 will be supplementary. Now, if you have isosceles trapezoids, what that means is that you have one pair of parallel sides, and the legs or the sides that connect the parallel sides are congruent. Also, you have congruent diagonals. So these diagonals are going to be the same length. It also will have base angles congruent. So base angles are angles that touch the bases. The bases are the sides that are parallel. So this angle right here and this angle right here are base angles because they are touching the bottom base. Those will be congruent. Up here, this angle and this angle, these are base angles because they're touching the top base. Those are congruent. And one other thing, your opposite angles will be supplementary. So this angle down here and this angle up here will be supplementary. That's a lot to remember. Here's a really easy way to remember most of these properties. Think about your trapezoid as being able to fold in half. Okay, I can fold that trapezoid in half. The angles that land on top of each other will be congruent. The sides that land on top of each other will be congruent. Maybe that helps. Hopefully it does. So for example, here, number 1, I have trapezoid JKLM. This is a non-isosceles trapezoid because its legs are not congruent, but the properties of non-isosceles trapezoids will still work. So your consecutive angles between your parallel lines are supplementary. How am I supposed to remember that, Ms. Grandy? Well, you already know this. Remember when we learned parallel lines? Here are your parallel lines. Here's your transversal. These are same side interior angles. We already know that same side interior angles are supplementary. So I could have given you this exact problem way back in Unit 3, and we still would have been able to solve it because we know that same side interior angles are supplementary. So we can say 180 minus 87, and that will tell me angle M. So it's 20. It's an 87. Hold on. Got it kind of messy. Yeah, it's an 87. Okay, so 180 minus 87, we get 93. So 9 is a 93 degrees. And then for K, well, here we have our parallel lines and a transversal. So we have same side interior angles, consecutive interior angles. So 180 minus 51 will tell me the measure of angle K, 129 degrees. Go ahead and try number 2. What's the measure of angle C? What's the measure of angle D? Let's try those. So you should have gotten the measure of angle D is 118 degrees, and the measure of angle C is 149 degrees. In number 3, we're going to solve for angle X, or for X. So we're going to have to use a little more algebra than we did in the first 2 problems. You have your 2 parallel lines, your transversal here. These are same side interior angles, or consecutive angles in your trapezoid. Either way, we know that these are supplementary. So we can add these 2 angles together to get 180. Combine your like terms first. Subtract 60 from both sides, and then divide both sides by 8. So X equals 15. And in number 4, we have a non-isosceles trapezoid. The top and the bottom are our bases. Angle Q and angle R are labeled. Let's find the measure of angle R. So first we find X, plug it in, tell me what is the measure of angle R. Try this one. Do this one now. So you should have gotten the measure of angle R equals 57 degrees. When you add these 2 angles together and set them equal to 180, you can combine your like terms and get X equals 10. And then by plugging that 10 in for angle R, you get 57 degrees. Now we need to practice properties where it is an isosceles trapezoid. And the easiest way for these guys, honestly, is just pretend that you're folding them in half. So fold this in half here. Ooh, here. DG. Well, here's DG. If you folded that in half, what side would it land on? EF. So DG and EF are congruent. And then it says DF. Okay, well, DF is a diagonal in an isosceles trapezoid. Diagonals are congruent. So the other diagonal here is EG. Looking at number 6, picture folding this guy in half. What angle is congruent to angle T? What angle is congruent to angle V? Right, angle T is congruent to angle U, and angle V is congruent to angle W. In number 7, let's picture folding this isosceles trapezoid in half. So if angle P is 112, then angle Q is also 112. Okay. Now the properties for the non-isosceles trapezoid still hold here because you have parallel lines and a transversal. So this angle P and this angle S are going to be supplementary. So if I do 180 minus 112, that tells me that angle S is 68 degrees, which also tells me that angle R is 68 degrees. Go ahead and try number 8. Tell me what is the measure of angle W, angle Y, and angle Z. Try those now. So for angle W, you should have gotten 47 degrees because angle W and angle X are congruent. And for Z and angle Z and angle Y, those are both 133 degrees. When you do 180 minus 47, you get 133. And angle Z and angle Y are congruent. All right. Here we have a few examples where we are going to be using a little more algebra, but the ideas are the same. I'm just going to use a little more algebra to solve. In number 9, we know we have an isosceles trapezoid because it tells me in the directions. So as soon as it says that, I'm going to go ahead and mark just MP and NO congruent. It also says the MP is 16x minus 13, so I'm going to go ahead and write that here. NO is 9x plus 8. PN, well, that's the diagonal. PN is 5y plus 19. And it tells me MO, the other diagonal, is 12y minus 37. You can see why they didn't actually label it in the picture because it gets kind of messy. But knowing those things, we can solve for x and we can solve for y. We know that the legs in this thing have to be congruent. So we know that 16x minus 13 has to equal the 9x plus 8. We also know in an isosceles trapezoid that the diagonals are congruent. So I can say that 5y plus 19 is equal to 12y minus 37. And now that I have those two equations, we can just use algebra to solve them. I'll let you pause the video if you need to follow the steps, or you can just trust me. X is going to equal 3, and Y is going to equal 9 or 8. I know I skipped a bunch of the algebra steps here. You're welcome to pause the video and work them out. Make sure you can get these answers. The setup here, though, is the main part. If you can set it up, then hopefully by this point you can solve these. Okay, in number 10, we have an isosceles trapezoid. We're going to find the measure of each missing angle. So first you're going to find the measure, or find the value of x. Take that x and plug it in for D and C, and then you should be able to find the measures of angle A and angle B. In number 11, they're giving us angle J and angle M. Solve for x, and then plug that x in and find the measures of angle K and L. I want you to go ahead and try number 10 and 11 and do that now. Okay, in number 10, they gave you angle D and angle C. So these angles are going to be congruent. Picture folding that isosceles trapezoid right down the middle here. So angle D would land on top of angle C, meaning they're congruent. So I can say that their expressions are equal, and I solve for x and I get 13. When I plug that 13 into angle D, I get 53. You could plug it into angle C, you still get 53. So angle D and angle C are 53 degrees. Now, angle A and angle B, those are not going to be 53 degrees. Those angles are supplementary to D or supplementary to C. So I'm going to do 180 minus 53, and that's where the 127 came from. So angle A is 127 degrees to make that supplementary to the 53. Angle A and B are congruent, so they're both 127 degrees. 11, the setup was different because they gave you angle J and angle M. Angle J and angle M are not congruent, those are supplementary. So we add them together to get 180. Solve for x, we get 14. Then when we plug that x in for angle M, we get 73 degrees. And when you plug the angle, or that x in for angle J, we get 107 degrees. Angle J and angle K are congruent, so angle K is also 107. Angle L and angle M are congruent, so angle L is also 73 degrees. All right, there are 3 more practice problems here for you. I'm going to let you practice these on your own. You're welcome to pause it and work through them, look at the answer key, see how I did. This video is starting to get a little long, and these are the same properties we were just practicing, so you're welcome to practice these on your own. We do need to go over one more idea, and that's the mid-segment of a trapezoid. The mid-segment of a trapezoid connects the midpoints of your trapezoid, and we saw something similar to this when we talked about the mid-segment of a triangle. Okay, so this trapezoid is just a triangle with this top cut off. Okay, so if EF is the mid-segment of a trapezoid, then you're going to have 3 parallel lines. EF will be parallel to both bases. When we had a mid-segment of a triangle, the mid-segment was parallel to the base of the triangle. We'll now have 2 bases. So it's the same idea. AB will be parallel to EF, and that will be parallel to DC. So if you have a mid-segment, that mid-segment is parallel to the bases. And the other important property is that the mid-segment is half the sum of the bases. So you're going to add the top base and the bottom base together. When we had our mid-segment of a triangle, it was half of the side it was parallel to because it only had 1 base. But now in our trapezoid, we have 2 bases, so it's half of the sum of the bases. If you don't like that half, you could also write it as 2 times the mid-segment is equal to the sum of the bases. Gets rid of the fraction there for you. Whichever way you like best, they are both going to work. Okay, so in example 1, you have, it says AB is 14. AB is the top base. You have your mid-segment. DC is 26. Find the mid-segment X. Here, this is super easy. Ready? The mid-segment is half of the sum of the bases. So 14 plus 26 divided by 2, you get 20. Okay. So that's if you're looking for the mid-segment. What happens if it gives you the mid-segment and it's asking you for the base? I'm going to sketch what it looks like here. EF is 22, that was the mid-segment. DC was the bottom base, that's 38. Find AB, that's the top base. The mid segment is half of the bases added together. Okay, you can multiply both sides by 2 if you want to get rid of that fraction. You could also distribute the 1/2 if you really want to. Subtract 38 from both sides here, 6, so x equals 6. So in this case, I let that AB be equal to x. So AB is really 6. Okay, so if you are trying to find the mid segment, that's the part that's going to go out here in your equation. If you're trying to find a base, then one of those bases becomes your variable instead. Okay, so you have to ask yourself, am I looking for the mid segment or am I looking for a base? Maybe sketch the picture and then plug it into your formula. Go ahead and try number 2 and number 4 here. In number 2, find the length of EF, and in number 4, find the length of DC. Go ahead and try those. All right, so for number 2, you should have gotten EF as 19, and for number 4, you should have gotten DC equals 53. If you want to know if your answer makes logical sense, you can ask yourself, well, does it actually make sense for this picture? So in this picture, AB is shorter than EF, and EF is shorter than DC. So because in number 2, we got EF is 19, 19 is bigger than 7, but smaller than 31. So logically, that does make sense. And if you add the 7 and the 31 together, half of that sum is 19. And then for number 4, we were finding DC. DC is 53. That's longer than EF, so that does make sense. You can go ahead and check your work with what you see on the screen, and let me know if you have any questions. The next examples are just examples that use algebra. I'll do one of them with you and then let you do the other 2 on your own. Let's look at number 5. We know that YZ is the mid-segment. So the mid-segment itself is half of the sum of the bases. So the first base was 38 and the other base was x plus 14. That's the algebra part. And now we just have to play, that was the geometry part. Now we just play algebra with this, solving for x. And then we'll take that x and plug it in to find YZ. I don't like this 1/2. I don't like distributing a 1/2. So I am right away off the bat going to multiply both sides by 2. Okay, so that gives me 10x minus 19 times 2, which is 38. And then this 1/2 times 2 cancels out. That's why I did it. Now I have 38 plus x plus 14. Combine your like terms. So 10x minus 38 equals, well, 38 plus 14. That gives me 52. I'm going to subtract an x from both sides. So that gives me 9x minus 38 equals 52. Add a 38 to both sides. So that gives me 9x equals 90. And then divide both sides by 9. Now that I know that x equals 10, I can find YZ by plugging that 10 in. 5 times 10 minus 19, or 50 minus 19, and I get 31. Okay. I'm going to let you practice the last 2 on your own, just remembering that the mid-segment is half the sum of the bases. At the end of this packet of notes, you will find kind of a flow chart for all of the quadrilaterals that we've talked about. We talked about parallelograms, rhombi, rectangles, and squares. We've also talked about trapezoids and isosceles trapezoids. You might want to print this out and just kind of keep it nearby as you're studying. I don't mind if you use it on an exit ticket, but you can't use it on a quiz or a test. Hopefully the visual does help. And if you have any questions, please reach out to me and let me know. I know that we covered a lot in this PlayPosit. Hopefully the trapezoids wasn't new. It was something that you've learned about before in the past. Hopefully it was a review, fingers crossed. If it wasn't, please reach out to me if you'd like any extra help or any extra practice. I'm happy to help. I hope you all have a wonderful day,